Hi, my name is Samuel Gino, and together with Divyansh Goyal, we are presenting our sandbagging detection algorithm. What is special about our algorithm is that we will never label as honest a model which is actually sandbagging. This is important to us because we are concerned about very capable models who might suspect that we are monitoring them and would therefore attempt to sandbag in a different way than what we are monitoring for in order to evade detection. We are hoping to avoid this by very precisely defining sandbagging and proving that our algorithm always manages to catch sandbagging. The details are in the report, but let's hop into the demo where we will be applying our algorithm to a very small model. The model is very small because we have handcrafted the weights of the model so that we know the ground truth. We know whether the model is sandbagging or not because we have designed one model to sandbag and other models to be honest. Let's not look at the weights, let's look at the behavior of the model. Here is a visual representation of how the model behaves on all possible inputs. All of the models in this demo are trying to compute some function, adding some numbers, but they are not very good at it. Here you can see that for some inputs, for some columns, the model is answering correctly. The color of the background is the same as the color in the circle, but for other columns, the color of the background is different from the color of the circle. The model is answering incorrectly, and so we mark those circles with a red outline. The model is sandbagging. It is only pretending to not have the capability of adding numbers, because there is a circumstance, namely this circumstance here. Each row is a different circumstance. The circumstance 0110, perhaps representing when the model has been deployed to production, is a circumstance under which the model does exhibit the capability. It is actually able to add the numbers. We want to detect this, but we cannot do this by just testing, because testing is one of those circumstances before production, say 1101, where the model is exhibiting the lack of capability. So how will we be detecting this? Well, we are using the opposite approach. We're trying to detect whether the model is honest, and if we cannot prove that the model is honest, we say that the model is possibly sandbagging. So here you can see that a sandbagging model has somewhere a row where all of the circles are with a black outline. Our algorithm is looking for a column where all of the rows have a red outline, because if we can find one, then we know that there are no rows where all of the circles have a black outline. For this particular model, there are no such columns, because the model is sandbagging, and so we will not be able to find one. If I try, then we say that the model is possibly sandbagging, because we cannot find such a witness, such a column where all of the circles are red. Let's look at a model that is trying to answer a slightly different addition problem, where this model is honest. There are no rows where all of the circles have a black outline. And this time the algorithm will succeed because there is a column where all of the circles are red. And so we start thinking that the model might be sandbagging because we have not yet found a witness. I run the algorithm, and after a little while, we find that this column is a column where all of the circles are red, and therefore we can show that the model is provably honest. Now, how do I know that all of the circles are red? I'm not looking at all 16 possible circles in this column, because in fact there's an infinite number of inputs. I also want to make sure that there are no rows in between the circles that are answering correctly, and so for every input. And so I want to know that for every value in between the circles in that column, that the model is answering incorrectly. So I can prove that by using range analysis. So this code here is an equivalent representation of the weights. That is the mathematical definition of the model, right? ReLU of weighted sum. And instead of calculating the output of the model by giving it a bunch of numbers as inputs and getting one number as output, I'm giving it a bunch of ranges as input and calculating a range as the output. And I am guaranteed that as long as the input is within the input range, the output is going to be within the output range. So here, the range I'm using is representing this tall rectangle that contains this entire column. So if any input is within that column, then the output is going to be between 0 and 14.5. But the correct answer for this particular problem is 14.6, which is just outside of the range, and therefore we know that for this particular input, this is a witness that shows that the model is incorrect regardless of the circumstances, and therefore the model is not sandbagging. That was my project. Thank you very much.